Hey guys, my name is Sandeep Patel. In this video, we are going to solve a second problem on the recursion, right? So in this problem, we want to sum of all array elements. So let's say that we are given an input array, 1, 2, 3, 4, 5. We need to produce the output, like basically the summing all the elements, that would be the output, right? For example, 1 plus 2 is 3, 3 plus 3 is 6, plus 4 10, plus 5 15. So when we supplied the input array, we need to calculate the sum and for this example. Okay, in my recursion technique, I said that we can solve this recursion problem using two-step process. Step 1 is breaking the problem, and then step 2 is solving the sub-problem, right? So first, let's break the problem. And how do we break the problem? So we take the initial array, and each time we call the same function by removing one element from the array. Okay, so this is how we do step 1. Step 1, break the problem into sub-problems. And how do we do that? So we call the same function, and we slice 1. So basically, from the input array, we remove the first element, right? And we call the same function. So this is how we break the problem into sub-problem. So let's look at how this works. Okay, so let's say the first time we call some array function by passing 1, 2, 3, 4, 5, right? So now what happens is we remove the first element, and then we return this rest of the element and call the function again. So we made another call, right, by removing the first element. So the next call would be like this. Then it's going to call again. It's going to call again by removing 2 from the array, right? And then again it's going to call by removing the 3 from the array. So we're basically removing the one element from the array each time. So it's going to call again, and then again, and now the array has no more elements, right? But the function is not stopping here, right? Like it's still continuing, right? We can still go down, but that's where the second step is coming, right? So we are now at the point where we have this base case, right? Where there are no further elements, right? So we want to solve that sub-problem first, right? So let's solve this problem. So let's say that when array is empty, the sum of empty array is 0, right? So let's do this here. So step number 2, solving smallest sub problem, right? And how do we do that? So array.length, when array.length becomes less than equals 0, then we return 0, right? Okay, so we addressed that, right? But if you run this code, it's not producing the same output that you're looking, right? What it's going to do here is that when we encounter the array length equals 0, we return 0. Like at this point it's returning 0, right? So because this is in call stack, right, like this is a memory, like we still have to go back, right? So this 0 will be returned to the previous step, and then from there we're still returning the same 0 until it goes to the first step, right? So at this point, every step will return 0, right? Until it goes to the first step. And we run this code, and you can see, right? It's clearly not producing the output that we want. And there's a reason why, right? Because each time we're returning what is coming from the previous call, right? So let's say the previous call for this. So this is the first call, then second, third, fourth, 5, and 5th. So this is the base case, and we started returning from here, right? So when we return, so output of this function would be 0, right? And then output of this function would be the output of this function, which is also 0, right? We're returning same 0 upward direction. Okay, so how do we fix this? So notice this, like each time when we call the function, we remove the first element, right? What if we use that first element to sum, right? For example, let's say before we remove this, we can add this 1 plus, right? So now what we can do here is that we take the first array element and then we call the next remaining elements, right? So from the next element we can add this. Similarly, we can do 3 plus, we can do 4 plus, and finally we have 5 plus, right? And from here we can start returning, right? So this function will now return 0, right? Because that's a base case, right? So now so we still need to figure out the output of this function, which is output of this, right? So in this case 5 plus 0 is 5, so this function will return 5, right? Now 5 plus 4 is 9, so function return, the output of this is 9, and 9 plus 3 is 12, 12 plus 2 is 14, and 14 plus 1 is 15. So that's, so now we will have a correct output. And how do we do this? We can just take the first element of array and then sum, right? So we need to do that, and that would solve the problem. So if we run now, you see the correct output, right? So for empty array it's returning 0, for single element it's an element itself, and when we have more elements then it's going to do sum of all, right? And that's how we can solve this problem. Now the time to calculate the time and space complexity, right? So when we broke down the problem, right, when we had this line of code initially, right, so where we're basically doing is like we're slicing the array element one by one. So before, let's say we had this array, right, originally, which has length of, so 1 2 3 4 5, so there are 5 elements in the array, right? And then in the next call we remove the one element from the array, right? So now it becomes 4, right? And then we remove one more element, right? So now array size becomes 3, and then it goes all the way until array goes to 0, right? Array becomes empty, that means the length is 0, right? So we started from array length and it went all the way to 0, right? So basically it goes, so this recursion function will be called n times, right? Where n is the length of the original array, right? So we can say that this will return O of n, right? And we also have array 0 plus, right? So basically this line of code right here, that will result in O of n time, because this function will be called n times, right? And that is the bigger complexity in this code, right? This is O of 1 because it's not dependent on the input, right? So no matter how many times you run the code, this will run one time. So let's say for this example, this line will run only one time, right? While this line will run n times, right? So 5 4 3 2 1, right? So that's the time complexity of n. For space, we are not using any variables inside this function, so we should count only the call stack, right? So call stack is the number of call that we made, which is O of n. So the space complexity also be O of n. So I hope you like this video. Please do like, comment, and subscribe. Thank you.